Hey, welcome back to Release Radar. I'm Chris Biscardi, and today we're covering Google's multi-year effort to build a from-scratch operating system called Fuchsia. Fuchsia is Google's third operating system, behind Android and Chrome OS. It first became known to the public in 2016 and is open source. Now, getting involved in projects like Fuchsia is hard from the first time you download the code, which I did, and it took me 15 minutes. Even just talking about it requires knowledge of words that don't currently exist in other contexts, as well as words that take on new meaning in this new context. Fuchsia, for example, refers to the operating system, which is a collection of sub-projects. Fuchsia is not Linux, and contrary to popular belief, it's also not written in Rust, although some components are, as we'll see later. Fuchsia is comprised of a few components, such as a kernel, some user space programs, and a networking stack. But why are we talking about Fuchsia today? Because it's starting to roll out for first-generation Nest hubs. Not future generations, just the first one. Why Nest hubs? Because Flutter, the application development language in use on those hubs, can also target Fuchsia, which means that the operating system on these Nest hubs can be taken out and completely replaced with Fuchsia, while the application layer doesn't need to sustain any changes. This is partially due to Flutter's support for targeting Fuchsia, but it's an incredible achievement either way. And it's not even like Fuchsia got shipped to all of them immediately. It'll be rolling out over the next few months. So if we dive into what Fuchsia is, Zircon, which I think that's how you pronounce it. It used to be called Magenta, which is much more pronounceable, is the core platform that powers Fuchsia. Zircon is composed of a kernel as well as a set of user space services, drivers, and libraries necessary for the system to boot. Necessary for the system to boot, talk to hardware, and load more user space processes. Fuchsia builds a much larger operating system on top of these elements. Which brings us to the difference between kernel and user space. The Zircon kernel runs in kernel space, while user space is where most applications run. Typically, this kind of thing is represented as a ring-based permissions model, with ring 0 being where the kernel runs, and ring 3 being where your user programs run. 0 having more permissions, and 3 having fewer permissions. There's also 1 and 2 in the middle, just to be clear. But the way Zircon works, it focuses more on capabilities-based security models. Capabilities, if you haven't experienced them before, are more similar to the principle of least privilege that you see in serverless environments when running Lambdas. A Lambda will only get access to the things that it actually needs access to, such as a particular row in a DynamoDB database. The Linux kernel itself uses a protection ring and also has some additional capabilities-based functionality that you might be more familiar with if you've worked in the container ecosystem. So without getting deeper into the weeds, the Zircon kernel provides syscalls to manage processes, threads, virtual memory, inter-process communication, and more. Which brings us to one of the components that's written in Rust, a completely rewritten networking stack. NetStack 3, as it's called, is completely rewritten from a Go networking stack into a Rust networking stack, and it's another from-scratch development. Most of NetStack 3, approximately 90%, is platform agnostic, so you don't actually need to run the full Fuchsia in a virtual machine to work on the networking stack. It's a fully natural cargo project that you can use cargo check and cargo test to work with. But why choose Rust? If the whole kernel isn't written in Rust, why use Rust for different pieces? Well, to start off with, the old networking stack is written in Go, which isn't even an approved language for the project. A brief aside on approved languages. The Fuchsia project approves C++, Rust, and Dart as languages that can be used to build various components. Python is used for additional tooling, and Golang is completely disallowed, except for the old net stack. Even C itself is being phased out in favor of C++. Additionally, the old net stack for Fuchsia was owned by a different team, the gvisor team. And that team has different use cases, priorities, and goals than the Fuchsia team. For example, the gvisor net stack was not originally designed to run on real devices. You may be familiar with gvisor from, again, the container ecosystem. We won't be getting too much deeper into that, so if you're interested, go look at Kubernetes and the platforms it runs on. Fuchsia, on the other hand, does deploy to real devices, like the Nest Hub. It operates as a router and depends on dynamic configuration. So rewriting it from Go to something was a good choice, and it just happened to be Rust. We've covered a bit more of the software aspect of Fuchsia, and I expect that as Fuchsia rolls out to more Nest Hubs over the next year, that we'll end up seeing Fuchsia in more and more places. Which places is up in the air, but if Fuchsia tries to take over Android, it'll have a lot of politics to deal with on the way. Finally, one thing I wanted to mention is that the Fuchsia project contains a CLA, or Contributor License Agreement. If you were thinking about implementing one of these for your project, don't. It's not really the topic of this video, so I'm not going to go into it too much more, but suffice it to say, a CLA for your open source project probably isn't doing you any good, and increases the friction from potential contributors. While I'm probably not going to commit to the Fuchsia operating system in the near future, it is pretty exciting to see another full-blown from-scratch operating system released into the wild on public consumer devices, and I'm especially impressed with the way that it got rolled out under the Flutter application layer and without users noticing.